So here I have listed a couple of steps that you want to follow every single time that you balance a redox reaction. So the first step is to split up your reaction into two half reactions. One of them will be an oxidation, and the second one will be a reduction. Then you want to balance those half reactions first by atom, and then second by charges using electrons. Then you want to make sure that you have the same number of electrons in both of your half reactions, and then you'll add both of those half reactions together. And then depending on what kind of conditions we have, either basic or acidic, we may need to add hydroxide. So let's take a look at an example to demonstrate these steps. As you can see from this reaction here, we have a different number of atoms on both sides of the reaction, as well as different charges on both sides of the reaction. We've got a -2 charge on the reactant side and a +2 net charge on the product side. So you can tell that this is not a balanced reaction. So to start balancing this reaction, we're going to split it up into two half reactions. So we've got our I- and I2 in one reaction, and then MnO4- and Mn2+ in our second half reaction. So now that we've written our two half reactions, we're going to start balancing, first by atom. So you can see that on our reactant side of our first half reaction, we only have one iodine atom, but on our product side, we have two. So in order to balance this, we're going to add a 2 as a coefficient. Now this first half reaction is balanced by atom. For the second one, we have the same number of manganese, but not the same number of oxygen. So in order to balance this number of oxygen, we're going to add water to our product side. So since we have 4 oxygen atoms that we need to balance, we're going to add 4 H2O, giving us also 4 oxygen atoms on the product side. However, in the process of adding water, we also introduced H+. We also introduced hydrogen. So in order to balance this hydrogen, we're going to add H+. So because we have 8 hydrogen atoms that we need to balance, we're going to add 8 H+ to the reactant side. Now, this reaction is also balanced by atom. Oops. Once we've balanced everything by atom, we're going to balance next by charges. So, for this first half reaction, we have a -2 charge, net charge, on the reactant side, since we're taking this -1 charge and multiplying it by 2. On the product side, we have a net charge of 0, since I2 is its elemental state. In order to balance this by charge, we're going to introduce 2 electrons to the product side. Now, our net charge on our product side is also -2. And this half reaction, is balanced by charge as well. Let's look at the second half reaction. The net charge on our reactant side is going to be +8 plus -1 from the MnO4-. So our net charge is going to be -8 plus -1, or +8 plus -1. So our net charge is +7. On our product side, we have +2 and 0 from the water. So our net charge on our product side is +2. So in order to balance this, I'm then going to add 5 electrons to the reactant side. This now makes the net charge on our reactant side -5 plus 8 plus 1, or +2. So now this reaction is also balanced by charge. As you can see in our first half reaction, we have our electrons on the product side, which means that this first half reaction is an oxidation. In our second half reaction, our electrons are on the reactant side, and they're being gained. So this is a reduction. So we now have our two balanced half reactions. However, you'll notice that the number of electrons is not the same in both half reactions, and our aim is to get those electrons to be the same number. So what we can do is we can manipulate both of these half reactions so that we do get the same number of electrons. So if I take my oxidation half reaction and multiply each thing by a coefficient of 5, and if I take my reduction half reaction and multiply everything by 2, then we'll get 10 electrons on both sides. So it'll look something like this. Our oxidation half reaction will be 10 I minus converted into 5 I2 and 10 electrons. For our reduction half reaction, we'll have 10 electrons plus 16 H plus 2 MnO4 minus converted into 2 Mn2 plus and 8 H2O. And you can see here now that we now have the same number of electrons on both sides of our reaction. Now we're ready to add both of these half reactions together. So once you have the same number of electrons on both sides, we can add those half reactions together. Okay, so then when we add everything, we end up getting on the reactant side 10I minus plus 16H plus 10 electrons, and also 2 MnO4 minus. On the product side, we then have 5I2 plus 2 Mn2 plus 8 H2O and 10 electrons. Now, since we have the same number of electrons in both the reactants and product side, those will cancel out. And we're left with this as our final balanced half reaction. Now, if the question indicated that we had acidic conditions, this would be your answer. But if we have basic conditions, we're going to add hydroxide. So for every H plus that we have, we're going to add that same number of hydroxide to both sides of the equation. So since we have 16H plus, under basic conditions, we're going to add 16OH minus to both sides of our reaction. Then we end up getting 10I minus plus 16H plus 16OH minus plus 2 MnO4 on the reactant side. On the product side, we'll have 5I2 plus 2 Mn2 plus 8 H2O and 16OH minus. Now you can see that our H plus and our OH minus will combine to form water. So really, we're going to get 16 molecules of H2O. But we're not quite done yet because we now have 16 molecules of H2O on the reactant side and 8 molecules of H2O on the product side. So we can kind of combine some terms here. If we have 8 on this side, we can subtract the 8 from both sides. So we end up getting 10I minus 8 H2O plus 2 MnO4. And on the product side, we have 5I2, 2 Mn2 plus, and 16OH minus. And this would be your final reaction if you had basic conditions.